Hello and good evening. My name is Syahira binti Ismail. I'm from University Technical Malaysia Melaka. Today I would like to present about emerging technology and title and analysis of ice cream cone antenna for 5G application. There are 9 content lists in my project that I want to share. 5G promise improved performance, lower latency, and faster data rate for next generation devices such as the Internet of Things (IoT). Older version of antenna may not be able to match the specification for 5G mobile connection. The project aims to design an ice cream cone antenna 5G application and analyze the performance including gain, return loss, and radiation pattern. The 5G technology operating at 3.5 GHz can deliver high-speed internet at a rate 10 to 100 times faster than 4G technology and is equipped with superior connectivity. Using UV etching and printer processes, the antenna is created using CST Studio software. The popular statement of the project to give an option to the market for 5G antenna. The industry currently have a short set of antenna that can achieve the high standard required for 5G application. Although the demand for a wide variety of sophisticated and high-performance antenna is increasing. Second, enhancing the radiation efficiency and bandwidth of ice cream cone antenna for 5G network. To explore innovative design technique and material selection to optimize the radiation characteristic of ice cream antenna. Investigating the ice cream cone antenna design performed for 5G. The size and latency of 5G antenna, especially at a mid-band spectrum, a 5G mobile antenna should be compact in size comparing with the bandwidth and radiation efficiency requirement. There are 3 main objectives of the project. First, to design an ice cream cone antenna to be used on the 3.5 GHz frequency band for 5G application to meet 5G requirements. Second, to meet the demand for smaller antenna size and easy fabrication, the ice cream cone antenna was used to obtain high efficiency to ensure maximum data transfer. Third, to evaluate the performance of the ice cream cone antenna including gain, return loss, and radiation pattern through fabrication and measurement result using the proposed CST software based on simulation. The main achievement of the project is to achieve the target operating range between 2 GHz to 5 GHz with frequency range return below 10 dB to provide a strong band antenna. The CST 2021 software used to design antenna and simulate the basic parameters such as gain, return loss, and the radiation pattern. The antenna is aligned with the parametric method to achieve antenna method operating at 3.5 GHz. The ice cream cone antenna is designed with a combination of circular, triangular, and rectangular patch. In the fabrication part, the ideal antenna configuration will be produced using FR4 substrate material with a relative permeability of 4.3 and the thickness of 1.6 mm. FR4 is the most widely used material in PCB construction. Then, the antenna printed FR4 board will be fitted with SMA port to be connected and tested using vector analysis and HNF chamber. Finally, the software output and fabrication result will be measured and compared to produce conclusion. By using the proper ice cream cone antenna, it is expected to design and simulate the advanced era of antenna and help improve the way antenna work in the 5G technology. The methodology and development process of ice cream cone antenna for 5G application can be summarized and simulated in the following flowchart figure 1. There are 4 steps of project implement flowchart. Step 1 literature review is start to background and research and literature review and go to identify principle in design antenna, and next to step system modeling, design the antenna which parameter gain, return loss and direction pattern using CST. Next, simulation the antenna using software CST, and is the objective achieved or no. If no, we back to the design antenna which parameter again, return loss and direction pattern. If project achieved, we proceed to step 3, testing the result by fabrication ice cream cone antenna and measurement the antenna performance. Is the objective achieved or no? If no, we back to fabrication again. If the objective achieved, we proceed to step 4, perform analysis by record and analyze the data and go to the final report, and last the end of project. The CST software used to design antenna and simulate the basic parameter. The table 1 shows the parameter specification of antenna. As you can see, the frequency range 2 GHz to 5 GHz. Frequency design we need 3.5 GHz and return loss must be below 10 dB and radiation pattern are unidirectional. In designing process, there are 3 steps need to be done to produce antenna, which are design, structure or material, design, parameter and design process. For design, structure and material, the structure represent in time 3D. The substrate use dielectric material such as FR4, relative permittivity 4.3 and the thickness of 1.6 mm. Best I use is copper material. And next, design parameter. For design parameter, refer to dimension of structure. Antenna performance is dependent on the antenna dimension. And design process and simulation. Design process is how to find or identify the design parameter value in order to achieve design specification meet their performance. CST software allows us to simulate the performance of the design antenna such as return loss, gain and direction pattern. The major parameter of the antenna must be compared with the parameter that have been simulated to prove the actual performance of the antenna. If the performance of the antenna cannot be matched as simulated, then the process of identify the problem and troubleshooting must be done. For vector analysis, it used to measure frequency response and return loss antenna. An antenna chamber used for R4 antenna chamber including testing antenna and radar and perform measurement of antenna direction pattern and electromagnetic interface. Antenna design calculation based on the derivation regarding on the components such as thickness of copper, dielectric, thickness of the substrate FR4 and frequency. The antenna is designed with combination of circular, triangular and rectangular patch. As you can see, this calculation to create design ice cream cone antenna. The circular patch antenna calculation process for calculation of the radiation antenna, and this triangular patch antenna calculation process for the length of the trigger. Microstrip patch antenna calculation process. Calculation focus on width and length. This is the symbol of parameter I use to calculate antenna design. Figure 2 show top view, the back view and the perspective of view the ice cream cone antenna after parametric machine using CFT Microwave Studio simulation. The result frequency is used as 3.5 GHz and the antenna size is 45 mm at 30 mm. The expected return loss must be less than 10 dB. The dimensional parameter of the antenna design are given in the table 2 below. Figure 2 show the antenna that have been fabricated by using UV etching and printer processes. Figure 4 show the illustrate the return loss, also known as the parameter simulation for the ice cream cone for different length of the antenna feed line at different antenna frequency. The table 3 shows S11 which different length as antenna feed line at different frequency. The antenna display the return loss below 10 dB for length of 0.6, 1.2, 1.8, 2.4 and 3 mm. Figure 5 show the difference in antenna feed line sample width at different frequency, and the select feed line length is 0.6 mm. So table 4 show S11 with different width as the antenna feed line at different frequency. The antenna display a return loss of below 10 dB for width of 3, 4, 5, 6 and 7 mm. In comparison, the feed line diameter of 3 mm and 0.6 mm is better because all return loss or truth of frequency rate are generated around below 10 dB. Figure 6 show the S parameter result of the ice cream cone antenna operating between 2 and 5 GHz, which the feed line show previously. Findings show that 3.5 GHz is used to obtain resume frequency and return loss is negative for 7.820 dB. This indicated that the signal at 3.5 GHz received during transmission is robust enough to produce accurate draft data. The figure 7 and figure 8 display the polar view of the radiation at PHI 0 degree and display the polar view of the radiation at PHI 90 degree perspective. The direction of the main lobe of the antenna is 4.89 dBi at 0 degree in the PHI 0 direction. The angular width is 90.5 degree shown in the figure 7 at PHI 90. Figure 8 show 4.94 toward the main lobe of the antenna at 9.0 degree. The angular width is 106.8 degree. The result of the radiation pattern in polar view at PHI 90 degree show the antenna gain is expressed as 0.5292 dBi and the directivity value is 4.934 dBi. Figure 11 shows the measurement result of the S parameter for the ice cream cone antenna on the 0.6 mm and 7 mm feed line. As you can see on the table 5 show the result of return loss measurement below negative 10 dB in the frequency range of 2 GHz to 5 GHz. The return loss result for at 27.82 dB. The required operating frequency is 3.5 GHz, but the measurement result is 3.42 GHz, which is still acceptable in wireless application. Fabricated antenna values are slightly different due to the sound loss, such as the vector, the network analyzer probe screw on the SMA connector and free space loss. The graph shows the analysis of parameter S11 between simulation and measurement on the ice cream cone antenna in figure 20. The result frequency was changed from 3.5 GHz to 3.42 GHz by comparing the simulation result from the CST software with the fabrication data. The return loss of the antenna for simulation is 47.82 dB compared to the fabrication measurement, where the return loss is negative to 7.82 dB. This indicated that the antenna transmits more strongly at the 3.42 GHz. Figure 3 shows the comparison radiation pattern EV between simulation and measurement, and this is the progression radiation pattern HV between simulation and measurement. So, the conclusion of the project is analog of ice cream cone antenna have been provide valuable insight into their performance and application potential by studying its design, feature and operating parameter. The ice cream cone antenna can operate at resound frequency 3.5 GHz. It also offers a compact and low-profile design, making it the ideal for integration into a variety of wireless communication systems and devices. In terms of the radiation pattern gain performance evaluation, the antenna have been evaluated in terms of the radiation pattern gain, independent matching and bandwidth. Antenna can be optimized through proper design and dimension. The bandwidth of ice cream cone antenna can be increased by carefully choosing the cone geometry and dielectric material. Future work can focus on further optimize the radiation characteristic of the ice cream cone antenna. For improvement, the antenna can use various techniques to improve the gain and operate in the dual band of 3.5 GHz and 6 GHz. To improve the antenna gain and return loss, more work such as the use of the other dielectric material might be done. This is the reference I got while conducting the analysis of the project. So that's all for me. Thank you.